Hello all, I'm Shilpa Pimpalkar, working as Assistant Professor in the Department of Computer Engineering at AICMS Institute of Information Technology Pune. I welcome you all for the session of demonstration of implementation of a symbol table using Flex. Today we'll discuss about what is symbol table and how to create symbol table using Flex. Symbol table is important data structure created and maintained by compiler in order to store information about occurrence of various entities such as variable names, function names, objects, classes, interfaces, etc. When lexical analyzer is scanning source code, it may find a regular expression for variable name, function name, object, classes, and interfaces. Those entries will be scanned by lexical analyzer and will be stored into the symbol table. Symbol table is used by both lexical analysis and synthesis phase of the compiler. So it is used by all the phases where analysis of code is done as well as synthesis also done. Symbol table may serve following purposes, like to store the names of all entities in a structured form at one place, to verify if variable has been declared, to implement type checking by verifying assignments and expressions in the source code are semantically correct or not, to determine scope of a variable, that is for scope resolution. For implementation of symbol table, we are going to use Flex tool. It takes a specific format. You need to give lex specification when as a part of generating lexical analyzer for compiler. We are designing symbol table as a part of lexical analysis process. Action of lexical analyzer will be to create entries into symbol table. So we are going to follow the same format: definition, rule, and subroutine section. So this lex file we are going to create, which is having these three sections. In rule section, we are giving a pattern, and action will specify what is pattern and action for creating entry into symbol table. These are steps followed for generating lexical analyzer. As a part of actions of lexical analyzer, we are creating symbol table entries using linked list. So these are steps which are followed for generation of lexical analyzer. Like .l file we are giving as an input, it is going to generate lex.yy.c. We are giving lex.yy.c to the C compiler. It is generating executable. For this executable file a.out, we are giving input stream source code we are giving, and it is generating for us sequence of token. Now let's discuss how to write this lex specification, because our focus is on writing this lex specification. So for writing lex specification, as we have discussed, lex specification is given in three sections: definition, rule, and subroutine. In definition section, we are going to give one structure. We are going to define one structure. This is structure we are defining in definition section. Why it is required? Because there are different ways that how you can store symbol table entries. We are following approach of the linked list. For creating linked list node, we are creating linked list nodes. So structure is required for creating this node. Each structure consists of ID and data type. So here if I am creating variable of type A, int is data type and A is a identifier for that particular data type. Variable name along with type. Like that chain will be followed, that how many data types. Usually what symbol table includes: a name of variable, type of variable, what is default value for that. For demonstrating here with a simple way symbol table implementation, we are going to create a node which includes only two things. One is data type and other is a variable name. So let's see how it is done. We are going to create lex file with three parts: declaration, in between percent we have rule, and after that we have subroutine section. Now what we are doing in a definition section, we are declaring structure which becomes a node of a linked list. We need pointer to that linked list. Initially head, temp and current we are creating for relevant actions which we have specified here. What is regular expression in this? This is a pattern and this is action. Usually when here we are demonstrating for declaration type statement, symbol table entries will be created for declaration statement. Like if in source code I have int a comma b comma c, it is going to create symbols into symbol table like abc of integer type. So once I find in source code data type int float char, it is going to create one node, head node will be created and data type will be inserted into this. While scanning, first we'll get data type and then we'll get this value. First it will add data type yy text holds the lexeme which matches with this regular expression, right? So it is going to add data type. Next we are going to add here actual variable which is found. So it is going to copy that in id. Please note here we are copying in id. Id is different and data. Id is the name of variable where we are storing. Now one possibility is that in source code you may have statement like int a comma int a comma b comma c. So you want to store multiple variables with same data type like a b c d, all variables with same data type. So if comma is given in that, you need to retain a same data type. You need to retain same data type. So we are creating here temp node, temporary node for another data type like int a comma b. I'll write here int, suppose you have int a comma b comma c. So with first scanning you'll get this a as data type, but what if after comma you are specifying b? B is also associated with same data type. That's why we are giving here action for this comma. If comma is encountered, then you need to retain the same data type int, right? If comma is not there, then you have done with and you are terminating, semicolon will be there. If semicolon is there, you are marking end of head of next will be equal to temp. That is last node will not point anywhere. You are properly terminating that particular linked list. Once you click on enter button after entering this, if you click on enter button, then it will display this particular action I have added for display. Now let's see execution of this. Okay, I need to compile first lex.yy.c, then dot slash, you can see here now a dot out is present, dot slash a dot out. If I give int a, it is working, it is creating symbol table entry and it is displaying. Now if I give b comma c, it is retaining previous as well as it is appending to that list. You can note here how I am creating the symbol table entries. Now here data type is different, float. Like this you can go on appending different variables. So this is demonstration of how to create this particular symbol table using flex tool. Now if you see code which I have written or .l specification which I have given, sim.l, you can see here this is file which I have, this is declaration part. Like you learned already in second year that how to create linked list. Same way we are following as action. Please note here as an action we are specifying that what action this lexical analyzer is doing. As soon as it notices that variable declaration is there, it is going to create entries into symbol table. So for int, for variable name, this is pattern for variable name, for comma, for semicolon, for slash n, different actions we are specifying. As soon as, if you note here, I'll execute it again. Int a semicolon. As soon as the semicolon is entered and I press enter button, action for slash n will be taken. What action we have taken for slash n? It is for displaying. Display everything which is present in that particular linked list starting from the head. So I'm creating here current node and current node is pointing to head. So this is traversal of linked list, right? So in this session we have discussed about how to create symbol table entries using linked list, and we have used here lex specification and we have executed it using flex tool.